Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. At the isoelectric point, the molecule exists predominantly as a Zwitterian dipolar ion, where the positive and negative charges cancel each other out. Moving on to the next step. At the isoelectric point, the concentration of cationic form, fully protonated, net positive, equals the concentration of anionic form, fully deprotonated, net negative. This is true because the net charge is zero, meaning positive species and negative species are present in equal amounts, balancing each other. Moving on to the next step. The net charge on the molecule is zero at the isoelectric point by definition. The Zwitterian has equal positive and negative charges internally, resulting in no net charge. This is true. And for the final step. At the isoelectric point, the Zwitterionic dipolar ion form is at its maximum concentration. The equilibrium strongly favors the Zwitterian form at this pH, as it is the most stable form. This is true. Since all three statements, A, B, and C, are correct descriptions of what occurs at the isoelectric point, option D, all of the above is the correct and most complete answer. Therefore, the correct answer is D. Therefore, the correct answer is option D.